All right, we're on to part 2 of solving a system of equations with a matrix. So in part 1, we learned about how to make an augmented matrix for a system of equations. That's actually just the first step of solving the system with a matrix. So our first step is to create an augmented matrix for the system. And then step 2 is going to be to take that matrix and put it into what is known as reduced row echelon form, which is a mouthful and kind of a lot to write and to say. Is there a way we can write that shorter, Miss Ryder? There sure is. So we're going to do, instead of writing this all out, we're just going to call it RREF, which obviously stands for Reduced Row Echelon Form. Once we have the matrix in RREF, we're going to use that to write a new system that's equivalent to our system that's much easier to solve. So we're going to take sort of a complicated system, make it into a matrix, turn that matrix into RREF, use the RREF to solve. What the heck is RREF? Those guys totally know what RREF is, so they're going to tell us. All right, so RREF, first of all, any rows containing all zeros go at the bottom of the matrix. That might not happen a lot, but if it does happen that you get any rows with all zeros, they go at the bottom. The second thing is that if it doesn't have all zeros, you're going to have your first entry is going to be a 1. So the first non-zero entry in a row is 1, which is called the leading one. And then if a column contains a leading one, has all zeros for other entries. So a column containing a leading one has zeros for all other entries. And then we just like to have it in a nice order, so a leading one is always to the right of any preceding row leading one. All right, so there's our description of RREF. Now let's look at some examples so you can kind of tell what's going on there with this description. So for example, here's a matrix that's in RREF. It's sort of a big matrix, but that's okay. 1, 0, 0, 0, 6, 0, 1, 2, 0, 5, 0, 0, 0, 1, negative 3. Here's another example of 1, 1, 0, 0, 3, 7, 0, 1, 0, 2, 6, 0, 0, 1, 5, 9, and 0, 0, 0, 0, 0. So you can see both of these are following all 4 of the rules. Anything that has all zeros, this matrix has a row that's all zeros, so it's going to be at the bottom of the matrix. This one doesn't. First non-zero of any entry of a row is 1, so 1, 1, 1, 1, 1, 1. This one doesn't have any non-zero entries. A column containing a leading one has zeros for all other entries. So this is a leading one, everything else has to be 0. 1, 0, 0, 1, 0, 0. Same thing here. If there's a leading one, everything else has to be 0. These don't all have to be zeros because they're not leading ones in these rows. And then also, our leading ones are always to the right of any preceding one. So this one has to be to the right of that one. This one has to be to the right of that one. And that just makes a nice form. Now, like I said, once we have it in that form, we're going to now be able to make a new system that's much easier to solve. So, for example, now we're going to make a system from the RREF. Oh, those guys are in trouble. Here comes the cop after them. All right, so let's say that this is our row reduced form. All right, let's put this into a new system. So we can see we're going to have 3 variables and a constant. So we definitely have an x, y, and a z, and these are our constants. So our system would be 1x, 0y, 0z equals 2. So that would really just be x equals 2. This one, 0x, 1y, so y equals -1. And then 0x, 0y, 1z equals 5. And that's our solution. Our solution is, we have one solution, and it is that x equals 2, y equals -1, and z equals 5. Now you might have your system have no solutions. So here's an example of the matrix in row reduced form that's going to give you no solution. Because if we turn that back into a system, we get x plus 3y equals 5, 0x plus 0y equals 2. This equation has no solutions. There's never an x and y that makes that true. So we know that this system has no solution, which means our original system has no solution. And then you might have, and we know this is the case a lot, where your system is going to give you several solutions. So for example, 1, -2, 3, 0, 0, 0, 0. In that case, we get x minus 2y equals 3, and 0x plus 0y equals 0. This one is true all the time, so we can see this is the equation that's determining our solutions, and those solutions are infinite because we have an infinite number of x's and y's that make this equation true. So our solution is infinite solutions, and they all lie on the line x minus 2y equals 3. What the book likes to do is write this as individual solutions. So what we might want to do there is just make a parameter t, which is any real number, and then make one of our variables t, in this case maybe x is t, and then y would be t minus 2y equals 3. So t minus 3 equals 2y, so y is t minus 3 over 2. And so those are individual solutions. X is t, y is t minus 3 over 2, where t is any real number. All right, in the next video we're going to see how to get the matrix into row reduced echelon form so that we can do this last step.